Hello and welcome to the AI Research Roundup. I'm your host Alex, and today we're diving into some fascinating work in AI. We'll be looking at a paper called TikZero, Zero-Shot Text-Guided Graphics Program Synthesis. So the main idea here is about generating figures, like charts or diagrams, directly from text descriptions. But the challenge is creating these figures as editable programs, say using the TikZ language, which usually requires lots of specific training data, pairs of text and code, which is hard to find. TikZero tackles this by, using images as a kind of middle step. It separates understanding the text from generating the graphics program code. This lets it learn from separate piles of data, like graphics programs without text, and images with text captions. And the cool part is it enables zero-shot generation, meaning it can create these graphics programs from text even without seeing direct text-to-code examples during training. Okay, so let's look at Figure 1. This gives us a nice visual comparison. On the left side, you see results from a baseline model called TikZV2, and on the right, you see the results from the TikZero Plus model, which is an enhanced version of TikZero. Each row shows the graphics generated for a specific text description, like a 3D contour plot or a neural network diagram. You can generally see that the TikZero Plus outputs, they seem to capture the requested details more accurately compared to the baseline. It really shows how this decoupled approach helps generate better results. Okay, so Figure 2 really helps visualize the data challenge I mentioned earlier. See, you have lots of images with captions over here, and lots of graphics programs over there. But the overlap, the graphics programs with captions, that's pretty small. Models like TikZ are stuck using only that small intersection. And others like TikZify can use the programs, but without text guidance. TikZero is different. It cleverly uses both the big pools of data independently, the captioned images, and the graphics programs, which is key to how it works without needing those direct text-to-code pairs for training. Okay, so building on that idea of decoupling, Figure 3 shows us the TikZero architecture itself during inference, how it actually works. You can see the two main parts we've talked about. On the left is the adapter network. This takes the text caption and processes it. Then, using these cross-attention layers, it creates a kind of synthetic image representation. This representation then feeds into the second part, the inverse graphics model on the right. This model, which can also work directly from real images as shown by the dashed line, takes that image input, processes it through its vision encoder and text decoder, and finally generates the actual graphics program code. Right, so we saw how TikZero works with its architecture. Figure 5 gives us a better feel for the actual targets. These are some representative examples from the .tikzv3 dataset the paper introduces. The kind of data it learns from or gets tested on. We've got like a recurrent neural network diagram here, some statistical distribution plots, a probability tree, and this transformer model layout. It really shows the variety and complexity, of the graphics programs involved. Speaking of examples, Table 7 gives us a direct visual comparison from a human evaluation study. You see the original reference figure on the left for each row, and then the outputs generated by different models. TikZV2, the zero-shot TikZero, the fine-tuned TikZero Plus, and even GPT-4o for comparison. The table highlights some of the best and worst-rated examples according to human judges using those green and red borders. You can really see the difference in quality sometimes. It visually backs up the idea that TikZero Plus and GPT-4o are often preferred by humans. So yeah, those visual comparisons in the table really drive home the point about quality. Ultimately, what TikZero brings to the table, especially its zero-shot ability, is pretty significant. It's this clever decoupling of text understanding and program synthesis that really opens doors. It makes generating complex diagrams from just text descriptions much more feasible, pushing us closer to AI that can truly understand and execute these kinds of visual instructions. Well, that's all the time we have for today. Thanks for tuning in to the AI Research Roundup. I'm your host, Alex.